Hi, Federico. Welcome to the podcast.
Hi, Robin. Thank you for having me.
It's a pleasure. Looking forward to this one. Let's begin with a little bit about yourself.
Okay, perfect. Um, so I'm a software engineer with a long-standing career in software industry, particularly focused on computer vision. I worked on biometric um, identification systems like face recognition um, and fingerprint
Hmm.
identification using machine learning.
Hmm.
And I had the opportunity to participate in several identification programs in the region of Latin America.
Hmm.
And these recent years, I've been specializing myself in the machine learning, trying to understand what's behind those black boxes.
Hmm.
And that curiosity drives me to start this project. Yeah.
Brilliant. So, background in sort of facial recognition and things like that. And now you're interested to get into the geospatial domain.
Yes.
Right. And you've been working on a project in particular. Do you want to tell us a bit about that?
Okay, perfect. So I prepare a model, a deep learning model to for semantic segmentation, identifying solar cells, photovoltaic cells in Brazil
Hmm.
using satellite imagery.
Right. So, solar panel detection over Brazil specifically. What was the first part of your process?
So the first part of the process was the selecting the data. Um, Being honest with you, at the very beginning, I didn't find the data set that I wanted. There's many data sets, but a lot of them use a very high resolution images, and I wanted to use more open resources. So I didn't want to use a very high resolution images or some of them from the tube roof of houses. So because I wanted to explore regions in Brazil to detect those panels. I prefer uh, to use other kind of images. So at the end, I decided to build my own data set.
Hmm.
So this was the first step, and I experienced with Google Earth Engine, uh, and I discovered the BDC, the Brazil Data Cube program, which is a pretty interesting program, open, and it uses Open Data Cubes technology, the framework. So it's an open framework. It used images from different satellite programs, Sentinel, Landsat, CBRs, which is a Brazil satellite program. And at the end, for my project, I decided to go for the Sentinel-2 images coming from Brazil Data Cube.
Right.
So
So they provide
um,
an API and you can request, images basically back as a sort of formatted data cube. Is that right?
yeah, that's it. The what they call the spatial temporal data. So I had access to those cubes where basically we have 2D information and the time axis also.
Hmm.
Um, so it was easy to understand. I had the opportunity to be in contact with the people that maintain the program. They were very kind. They also have examples to connect to the service that are available, that are open. So that helped me to build my data set.
Hmm.
So that's how everything starts.
Of course. Well, Brazil's a big place. Presumably you narrowed it down a bit.
Yeah, it's a huge country, huge region to cover. Um, so the first idea was to select a group of solar plants that are distributed in the solar corridor in Brazil, which is a region where there is not so cloudy, a lot of sun during
Hmm.
all the year, so it's perfect for solar energy. So I select a group of solar plants. At the very beginning, I select 24 from different sizes, different surroundings to cover a wide distribution of solar plants, let's say.
Mm.
So the big famous solar plants from Brazil, and also some plants that I know from my region. I live in Brasilia, so I know some small plants that I wanted to prove that the model detects those plants also in urban surroundings.
Mm.
Uh, so I built that selection of solar plants, and then basically the process, because I didn't count with a lot of images. I take different pictures from each one of the solar plants, moving my acquisition window around a central coordinates to
Hmm.
have more images.
Hmm.
So I use that technique for each one of the plants. So at the end, I gather almost 300 images from the plants.
Hmm.
They are 256 by 256 tiles, and I choose to take the three composite bands plus the near infrared band. All of them are available at the Brazil Data Cube
Hmm.
images.
Right. And then you already knew where these things were. I suppose you looked up on OpenStreetMap or something to find the precise location of these solar sites.
Yeah, I use some Google Earth, some researching about the position of
Mm.
well-known solar plants in Brazil. So I found and I confirm the location, the coordinates of each one of them. Then I cross the information with the images that I fetched from Brazil Data Cube,
Hmm.
and so I start building my sets. So basically, that was the process.
Hmm. Right. And to make the annotations, the truth labels, did you use some open labels or did you have to create those yourself?
Now I create that from scratch. At the very beginning, I remember that I use simple scripts that defining a threshold and using the near infrared band. I call that script the AutoMask script, where
Mm.
define that the decision threshold, I can filter the values of pixels in that band, so I can have a pre-mask of the image just
Hmm.
to gain time and do not uh, hand annotate every single pixel from scratch. I uh, share those scripts also with the project,
Hmm.
and so that helped me to gain time. But at the end, I use the Serval plugin from QGIS, which is a very simple and straightforward tool. So I finished every mask by hand. So this is how I prepare
Right,
those
okay.
binary masks.
So the plugin is some sort of widget that you can play with the thresholding or the range of pixel values that you're going to assign to the segmentation label. Is that right?
There's two steps. The first one is, as I mentioned, is a script phase where I set that threshold for every one of the
Hmm.
images. In fact, it is detected from the distribution because the near infrared band is more sensitive to solar cells. The solar cells absorb a lot of there's a very low reflectance for the pixels that belong to the
Mm.
solar cell, so it creates a nice contrast that is easier to filter with a threshold. So that was the technique, the first step.
Right. So you set the thresholds. You've now created your masks. How balanced was the data set? Like what percentage of pixels would be a solar panel versus not a solar panel?
Uh, Low, very low. I expected that, but I measure it. It's around 8% to 5 and 4%, depending on the sets. I have the
Right.
statistics.
Okay.
It's very imbalanced.
Right,
Yeah.
very imbalanced problem. Brilliant. So you've got your labeled data. I think you mentioned there's about 300 images. About 5% of the pixels are the class that you care about. What next?
Okay. So I had my set. So then I wanted to experience with various models and benchmark them. So, and before that, I create what I call the baselines. So I use very simple techniques, a random, a dummy classifier. I also use a model that use that threshold for the near infrared band as a
Hmm.
classifier also to know how it performs. I measure the performance of that one. And I also use logistic regression to build a baseline. And
Hmm.
then I start with the models, the specific models to this kind of work.
Hmm.
So I experience with UNet, FPN, UNet++, PNP. So I benchmark them with my original set.
Hmm.
And the idea was to select the best performing one. And after selecting the best performing one with this original set, see what happened if I add enhancement techniques like super resolution or interpolation,
Mm.
how that can change the performance of the model.
Right.
So this is the main idea of that second step of the working with the model.
So that's good practice. First, establish a baseline performance with a sort of pixel-based logistic regression or simple model, and then you spent time experimenting with CNN-based models to improve that. How did they score relative to each other?
Okay, the logistic regression was very, very low IOU. What I remember, it was a little bit more than 30% of IOU, Jacker index. And then using UNet, which was the best performing from the CNN models. Um, it's important to say that I use a UNet model using an efficient net encoder. Okay, so the decoder, it was the UNet, but I fixed the encoder using efficient net. And why I fixed that? Because I train everything on my personal computer, so I want a good balance between performance and resources.
Mm-hmm.
And I also used a pre-trained EfficientNet encoder using ImageNet set.
Mm-hmm.
So that was the idea, to fix the encoder and use other decoders as UNet, UNet++, PNP, etc. And the best performing combination was the UNet. It was quite expected, but it was very close to UNet++. And I reached with this first configuration 90% of IOU.
Mm-hmm.
So
Significant improvement. And I'm just curious, out of all the different neural networks you tried, how big was the spread? Were some pretty close, or was there a big range?
no, they were very close.
They were all very close, right?
Yeah, they were very close. The range was, let's say, between 80% and 90%. But there was a gap, where there was a difference in terms of time consuming also. The UNet combination with EfficientNet, it was very good in terms of speed.
Right.
Yeah. So others models took too long to train. Yeah.
Right. And did you write your own code for training the models, or did you use some existing framework?
I use PyTorch, and I use a very good library called segmentation model, which is available for PyTorch and for TensorFlow also. I decided to use PyTorch because being honest, my GPU in my personal computer works. It was easier to configure with PyTorch. So I use those libraries to do the combination of different models. So that's how I prepare that.
Great. So you trained the model, you've selected the best one. What did you do with it?
So then, after selecting the best performing one, I start experiencing with upscaling the images and see how it impacts the performance of the model.
So super resolution.
Yeah, I experienced with super resolution with the real innate super resolution GAN from Jintao. It's a general project. So I research about it, and it's possible to use with satellite imagery. It has not been trained specifically for satellite imagery. It's more general purpose. But I wanted to see what happened, how the performance changed, because it's a very accessible also super resolution model. And then I used bicubic interpolation to see what happened and compare both.
All right. And what was the outcome?
So I expect a better performance using super resolution, but the reality is that the super resolution, what happened? You know that two-folded images, increase. I have a first problem with the size of the images and and the training process, because we are dealing with much bigger images. For two-folded super resolution, 4 times the amount of pixels, four-folded, 16 times the amount of pixels per image. So I start needing to reduce the size of the mini batches during the training. So at the very end, when I use the bigger images, I needed to reduce the size of the mini batches to 1. Practically doing stochastic gradient descent, and so the problem was the time that it took to for the training. Comparing at the very beginning, that took me no more than 1 hour, and after super resolution, it took me 40 hours, almost 2 days training. And the interesting result is that at the end, the bicubic interpolation performs a little bit better than super resolution. It had so from these two options, I selected the bicubic interpolation because I wanted to deploy this model, and thinking in the deployment, it was also interesting to keep that good balance between performance and resources.
Right, very interesting. So you had, I think, 90% IOU before. You then applied bicubic interpolation. How does that impact the metrics?
I gain 4%, 4 to 5% of IOU. And with the super resolution, I almost reach the same results using ×4 super resolution. So as I mentioned, the bicubic interpolation gave me the same IOU with shorter training loops. So I finally decide to continue with the bicubic interpolation.
Yeah, very interesting. Because of course, if you're using a pre-trained super resolution model that's been trained on remote sensing imagery already, so it possibly brings some extra information into the task. Interesting avenue to explore. Brilliant. So you've trained your model, you've refined it essentially, and then what did you do with it?
Okay, so then after having my model, having the weights, so the idea was to deploy it, put into practice the model. So I start deploying the model in cloud. I select AWS. So I start building a pipeline. So I basically the pipeline that I prepare is I build a simple front end where I have the coordinates, the central coordinates of an extraction plus the north-south extension and east-west extension. In other words, the bounding box of the extraction. And this is the input for the pipeline. And then I build a web server as my backend point of entry. I build it using Flask. I use AWS Lambda, which contains that web server. So this was the point of entry of globally saying a simple 4-step workflow, where the first step, they are contained into a step function, AWS step function, that first I fetch the images from Brazil Data Cube that belongs to that zone of extraction. So basically, I prepare the tiles of 256 by 256 tiles according to the entry characteristic of the images for the model. So I prepare all the tiles that belong to the extraction in that first step. Then I apply the image enhancement, which is deployed and it's up and running, is the bicubic interpolation. So I have 4 times bigger images. And after that, I process all those tiles into the model. This is the third step of the workflow. So I have the predictions, and after having the predictions, I build as a 4-step reports. I print some statistics about the destruction, how many positive pixels were detected in each one of those tiles, which is which surface represents those pixels, to have an idea of which tiles detect where we have more pixels detected. So I print a final report that can be downloaded at the end of the process. So it's like an end-to-end machine learning pipeline using that input.
Well, congratulations. As you say, that's a pretty end-to-end you started, but just an idea, a place to go, and then you created a data set, you experimented with different models, you experimented with different ways to improve the predictions, and then you deployed it, and so somebody can go and try this out for themselves. I'm curious, what was the sort of the biggest thing that you learned in the whole process, do you think?
In general, consistency was key, because I had the opportunity to combine previous knowledge from my background, but I needed to learn a lot of new things. So consistency was key. Because there are many difficulties that present. Now it's easy to explain, but you know that do a hands-on project like that, you have some drawback, you have problems, so overcome each one of them was key, and advance step by step. And I had in mind some improvements, so maybe in the future I can continue improving the model. Like I didn't use a tile first. I didn't experience using other bands, so I only use RGB plus near infrared, but I didn't use other interesting available bands from Sentinel-2 that can help. Because of the I use a pre-trained model using RGB, I didn't want to add a lot of bands to stay close to the original weights. But it's something that it's pending. It's something that I want to experience with. And also, I'm not caching images. So the workflow right now, it takes a little bit long. It's available. So if everyone wants to try it, I can generate a token, and it's available for demonstration. So anyone can access to. So now the process takes a little bit long, because it's doing everything from end to end, from scratch. There's no caching images. I'm not caching images. Thinking in the idea of discovering or covering new zones, unseen zones, I prefer to do not cache images. So it's something that I would like to experience in the future. It will run faster. And maybe using a tile system like S2, experience with that. So it's an open project. I have many things to improve. but it was an enlightening experience.
That's great to hear. Well, thanks so much for sharing your experience with us. Lastly, if people want to follow along the updates to the project, which is the best platform?
Okay, so the app to follow the updates of the project, you can follow my project in GitHub. So I share the links. I also post it on my LinkedIn account. So my intention is to continue updating it and experience it with it in my free time. So that's it.
Brilliant. Well, thanks again for coming on, and we look forward to updates. We're also going to record a video demonstration looking at the tool that you developed. So I'll post a
Oh,
link to that in the show notes as well. Okay. Once again, thank you. Until next time, take care.
thank you for having me. Bye bye.